Okay, so in this next lesson, we went from graphing function rules. Now we're going to get some practice writing function rules. So I'm going to give you some kind of real life examples, and then we're going to have to write a function for those examples. So in example 1, it says a landfill has 50,000 tons of waste in it. Each month, it accumulates an average of 420 more tons of waste. What is a function rule that represents the total amount of waste after m months? So it would be a good idea to define your variables. I would define m as months, and maybe let's define w as the amount of waste. So we kind of think about these as inputs and outputs when we're talking about a function, or we think about which one depends on the other. Now I think that the amount of tons of waste depends on how many months have passed. So my function is going to be w waste is equal to, and we can write this a few different ways, but we're thinking about it starts with 50,000 tons, and it gains 420 more tons each month. So you can write this two different ways. I'm going to write this rate 420 times the number of months plus that initial 50,000. Another way you could write this, you could write the 50,000 first plus 420 times the number of months. Either of these would work, but the idea is that we think of this as like a starting value, this 50,000. We think of that as like a starting value. And then the 420 more, an average each month, that is our rate, okay? So I'm going to use those terms, starting value and rate, to describe some of these things, okay? So if you have a situation where you have an initial amount and it's adding or subtracting an amount over every certain time period, that's what we think about as writing our function, okay? So in example 2, we're going to write and evaluate a function rule. So this says a concert's seating plan is shown below. Reserved seating is sold out. The total revenue from ticket sales will depend on the number of general seating tickets sold. Write a function rule to represent the situation. What is the maximum possible total revenue? So to define my two variables for this situation, I'm going to define R as my total revenue, because we want to know the maximum possible total revenue, and that depends on how many tickets we sell. So our revenue depends on how many tickets we sell. So you can use T for tickets, that's fine. I'm going to use N as the number of tickets, of general tickets sold, general seating. So when we think about this, the reserved seating is sold out, all right? So for the reserved seating, we got to think about how much money, the reserved seating made us. So the reserved seating has 12 seats per row for 10 rows at $25 a seat or a ticket. So if it's 10 rows and 12 seats per row, the way we figure out how many seats are in the reserved seating, I would take 10 times 12, which is 120. So that means the reserved seating had 120 seats, and we sold out 120 seats at $25 a seat. So that means off of the reserved seating, we made $3,000. And that is our starting value, right? We started with this revenue before we add the general seating tickets. So if we were going to write our function, I think the easiest way, write our function, we start with our starting value of $3,000 of revenue that we've already made. We've already sold those tickets. We want to figure out how to find out our maximum possible revenue. So we're going to add, and let's just assume for right now we don't know the number of seats in the general seating. It would be $10 a ticket times N tickets, okay? $10 a ticket times N tickets. And to find out, this is saying if we sell n tickets. This isn't saying we sold out our general seating. If we sold out our general seating, I'm going to use a different color for this. Our general seating capacity, we find that the same way we find the reserve seating. We would take the number of rows times the number of seats per row. 30 times 16. So that tells us how many seats are in the general seating. So that's 480 seats in the general seating. So, in order to represent a sellout of every seat, we're going to evaluate our function when n, the number of general seats, is 480. Okay, is 480. So I know this is a lot of work and it's a lot of thinking, but we've got to piece things together bit by bit. So this becomes R equals $3,000 plus $4,800. So a sellout would give us a revenue of $7,800. So this problem has a lot of moving parts. We've got to do some extra work to think about what does it mean to sell seats. We've got to figure out how many seats we have and how much each seat costs. So this one is probably the most complex one I think I'd give you. So we're going to move on to another. So for example 3, this is going to be a nonlinear function. So when we write this, it is not going to have just a variable times a number, or it's going to have something different. So we're going to write a function rule for the area of a triangle whose height is 4 inches more than twice the length of its base. So that's a confusing statement, so we'll kind of pick that apart. It says, what is the area of the triangle when the length of its base is 16 inches? So this phrase, height is 4 inches more than twice the length of its base. So the height is always stands for equals 4 more than twice the base. 4 more means adding 4 to twice the base. So for us to write the function rule for the area, we're going to rewrite the area formula itself. The area is 1/2 times the base times the height. So I want to write this with just b as the variable. So this is going to be 4 plus 2b. And all I did, the reason I did this, 4 plus 2b, is because I know h is equal to this expression. So I took out h and I substituted in this expression. So if I'm going to distribute through 1/2 b, I'm multiplying each term here by 1/2 and by b. So 4 times 1/2 b, 4 times 1/2 is 2, so this would be 2b. 2b times 1/2 b, 2 times 1/2 is 1, and then b times b is b squared. So this is a nonlinear function because of this b squared, all right? Like I was kind of saying before, most of our examples are going to be linear functions because that is the concept of this whole unit is linear functions. So what I'd like is for you to try, just the guided practice, just try number 1, okay? Just try number 1. Number 2, don't worry about for right now. We're just going to focus more on linear functions right now. So just try number 1, answer parts A and B, pause the video, work through it, and then check your solutions with me when you are ready. Okay, so for this last guided practice, defining our variables, I defined C as cost, N as days. And it costs $15 per day. So the cost depends on how many days the dog is at the kennel. Now, when the dog gets there, they have to give it a flea bath so the dog doesn't get there and spread fleas. So you pay that $12 as an upfront cost. That's that's your starting value. 15 is your rate. So you have 15 times the number of days plus that flat fee of $12. So all I have to do to find the cost for 10 days is substitute 10 for N and then use order of operations. So that'd be 150 plus 12, which is $162. and then asking, does a 5-day stay cost half as much as a 10-day stay? The way I looked at this, I found the cost for a 5-day stay was $87, and then I divided the cost of the 10-day stay by the cost of the 5-day stay, and it wasn't half as much. For that to be half as much, the 10-day stay would be twice as much, 2 times the amount. So it's not half as much. And the reason that is because just because you double the days doesn't mean you double the price, because of that $12 initial cost you sink in. That's the reason half the time isn't half the cost. So this kind of concludes the notes. You're going to work on the quizzes. Make sure you're using your full name in the quizzes so you get credit for the practice. Make sure you're completing the checkpoints because you're getting credit for those as well. I'm going to update the grades at the end of the week so you can see your progress, but I'm trying to give you guys a chance to do the work and not have you be penalized if you don't do the work in the morning versus the afternoon. Okay? So make sure that you're logging in each day we meet. It's going to be Mondays and Thursdays from here on out. Mondays and Thursdays for Algebra 1. Okay? So remember that. Wednesdays is a work day. I'm not going to assign things on Wednesday, but I'm still going to communicate with you, especially if you're behind. So just keep that in mind.